Welcome everyone to VMworld session KUB 2957S, a pragmatic path for IT and app modernization with the VMware Tanzu portfolio. My name is Mike Koleno. I'm the Chief Architect of Modern Applications at AHEAD. Today I will be playing the role of developer. Alongside of me, I have Pam Coffey. Pam, you want to introduce yourself?
Sure. Hey, everybody. I'm Pam Coffey, a field CTO at AHEAD based in Atlanta, Georgia. For this presentation, I will be playing the part of the platform operator, or the operator. I'm a VMware admin with a long history of supporting vSphere for our developers to use. Now I want to up my game to be a platform reliability engineer or site reliability engineer as coined by Google. My job will be to operate the Kubernetes platform for use by Mike.
Thanks so much, Pam. We also have been working closely alongside of two individuals from the AHEAD team who've been extremely courteous and gracious to help us get the corresponding lab demos up and running. So want to give credit to both Nick Stankey as well as to Tim Curlis from the AHEAD side as well. Let's dive into today's agenda. First, we'll talk about the emergence of containers, as well as the prominent rise of app modernization and how both are causing significant change for IT organizations. Second, we'll use an analogy of Mount Kilimanjaro and highlight how the new skills and new technologies picked up by both developers and operators will need to be carefully plotted in a similar climb up the mountain. We always want to ensure that we avoid getting stuck on the mountain. So as we climb up Mount Kilimanjaro, we always need a plan. We want to show that we can set a slow and steady pace. And then after we've reached the summit, we want to determine what's next for our company as it relates to containers, embracing modern application architectures, and adventures ahead.
Virtual machines are still growing, but it's clear that the use of containers is exploding, in part driven by developers and their need to modernize applications. Virtual machines certainly aren't going anywhere, but as a VMware administrator, I'm going to need to also support containers as well as virtual machines. So why have containers exploded and seen this explosive growth? First, they're very, very portable. Developers can develop their application for a container and then it can run anywhere, on premises or any of the public cloud providers. They're also very lightweight since they only contain the application and components of the OS needed to run the application. If you remember, VMs describe the full operating system and the virtual hardware. Because containers are so lightweight, they also boot very rapidly. Where a VM might take 15 to 20 minutes to boot, a container will boot in seconds. This is critical for the rapid deployment of applications required in a modern world.
The emergence of containers have provided an opportunity for IT organizations to move faster. First, we have the ability to move away from incremental monolithic designs. We also have the ability to limit the arduous and regression and deployment cycles associated with monolithic applications. Through test-driven development, continuous integration, continuous delivery, we're able to move our containers out into production faster than we've seen with traditional applications and traditional hosting architectures. We also have the ability, as part of this new paradigm, to break down the siloed collaboration of development and operations. Lastly, we get ourselves out of the business of wrestling enterprise infrastructure and rely more on platforms like Kubernetes to run our applications efficiently in production. Today, our talk track is going to be focused around Mount Kilimanjaro and climbing to the summit of Kilimanjaro's peak. For those who are looking to traverse up the mountain and reach the summit, there are a handful of routes to get to the peak of Kilimanjaro. As developers and operators with these new technologies, we have similar paths and routes to be able to choose from. Today, in our talk, we're going to select the Marangu route. This route has a handful of stops and camps along the way as we trek up the mountain in order to reach Kilimanjaro's summit. Similar to the different routes that are provided here, organizations have a handful of options as it relates to instrumenting new technology and finding new skills in order to reach the mountaintop. Okay, let's dive in. Let's highlight where we'll start. As the developer, we have a development team that's primarily focused in developing .NET monolithic applications. These applications are deployed to VMs. These particular VMs are Windows Server VMs. And while we have continuous integration in place, our deployments for the most part are fairly manual for these applications. Pam, do you want to cover the operator?
Sure. For me, I've always managed virtual machines. I focus on virtual machines being available for developers. I also manage the vSphere platform, patching, deployments, upgrades, all of that kind of stuff. And of course, I also own Windows Server Management. So the OS and size of those VMs is very important to me.
At the end of our journey, as we climb up to the summit on Kilimanjaro, we'll also pick up a handful of skills along the way. From a developer standpoint, we'll learn how to build a microservice application and to deploy it in a container-based deployment. We'll also, for the first time, have exposure to an operating system outside of Windows Server because we will be deploying our microservice in a Linux container. The deployment of that Linux container will actually take place in a continuous delivery pipeline, which will be completely new to us as well.
And for me, I'm going to keep my VMware skills and still manage the virtual machines as I have in the past, but I'm also going to have to manage the container platform. I'm the operator of the platform, and I'm going to have to understand what container-based deployments are and how to mesh with Mike and your team. The containers will also be running in Linux, so I'm going to have to gain new skills there. And then there'll be all the day two operations for the container platform itself, updating it, securing it, monitoring, troubleshooting, etc.
Thanks, Pam. And similar to some of our friends in the VMware ecosystem who have already accomplished this particular journey already, Pam and I will have the opportunity, once we reach the summit, to take a picture, to celebrate our successes, and to gather all the lessons that we've learned along the way. So let's start heading out on our journey. As we approach the mountain, we want to set the stage for today's corresponding set of examples that we'll talk through. Today, we're going to talk through a fictitious company called the River East Trading Company. Now, this company's been around since 2007. There is a software as a service and an API-focused organization. They have a single monolithic application that is the money-making application inside of their vertical. The monolithic application was similarly created in 2007, and for the most part has three main components. The oldest API is the Markets API. It's very stable, very little iteration is required, and it was built in 2007. The second prominent API is the News and Information API. This has evolved quite nicely over the course of the last 8 years, but subsequently, quarterly iteration is still somewhat required. And then lastly, the newest addition to this monolithic application and service offering is our Analytics API. Based off of the excitement in this space, as well as new customers that this is able to attract, this is a very dynamic subproduct inside of this particular SaaS offering. We're going to use this particular example throughout the course of today's conversation to highlight the move from a monolithic architecture to a hybrid monolith and microservice-based architecture. Here is the traditional three-tier architecture associated with the monolith. We have a very old technology in Windows Communication Foundation, the three corresponding API controllers, a data access layer, and a Postgres database. All of this is hosted in Windows Server-based VMs. From an application standpoint, the WCF application, as we'll see, is deployed to IIS. And all of this is running and being controlled using vSphere. Okay, Pam and I are set off on our journey, and we approach the first camp, our base camp, where we'll subsequently go out and plan the journey ahead of us.
Thanks, Mike. Well, it sounds like I'm going to definitely need to support virtual machines and containers as we expected. And if we look on the left, this is kind of interesting. Virtual machines, as we know, run on the hypervisor. And the hypervisor abstracts away the hardware. But the application is very, very dependent on pieces in the operating system. And this dependency causes a lot of day two work for both me and the developer. So anytime I need to patch or upgrade the Windows OS, that impacts the monolithic application. So let's compare that to containers on the right-hand side. In the container, everything that the application needs from the OS and the application itself reside in the container. So the OS is abstracted away. The container engine runs in the container OS host, and that's where the operating system comes from. Of course, this could run on bare metal, but it still wants to take advantage of the hypervisor. We want to take advantage of the vSphere hypervisor. And why is the container so good for us? Well, it's much easier for Mike to develop, much easier for Mike to contain his own destiny where all the application and the application dependencies are. And again, it's portable. Anything running that container engine is going to run Mike's container.
Thanks, Pam. And similarly, the developer's plan will have a foot in both worlds as well. The monolith will continue to house both the Markets API and the News and Info API. But we're going to break out the Analytics API into its own microservice, and we're going to use .NET Core for that, which will allow us to deploy that particular microservice into a Linux container and have that deployed as well, alongside of the monolith. Modern applications are based on distributed microservices. To compare and contrast the monolithic world versus those of microservices, we need to take a quick look at both. Now, monoliths are single, large code bases, similar to what we saw with River East Trading Company, a single deployment artifact or single code project that contains, in our case, 3 different API controllers. This single code base ultimately slows down how effectively and efficiently we can update the application. It also limits how we can scale the application. Now, monoliths are traditionally run in VMs, but can also be run inside of containers. Microservices, on the other hand, are small modular code bases, typically in their own Git repositories. These particular applications are easier to update, easier to scale horizontally, and almost always run in containers. All right, we've had a chance to look at the infra and the ops plan, and we've looked at the developer plan as well. Let's review our route and overall plan as we move on from BASECAMP. Again, here's what our architecture looks like today. From our monolith running on Windows Server to the server being managed and the VM being managed by vSphere. If we contrast that to the route and the corresponding plan that we want to end with as we reach the summit, we're going to have a hybrid of both the monolithic application running on Windows Server as it does today, and our microservice analytics API application running in a container. We essentially need vSphere and Kubernetes in order to be able to host this application in the same place.
Okay, thanks, Mike. Sounds like we're going to need a lot of stuff in our backpack to go up the mountain. Certainly not everything on the screen is part of this talk, but the green checks indicate what we are going to need. We talked about modernizing the application the way Mike is going to do it. There'll be source code control, artifact repos. He's going to talk about CI/CD. We're also marrying dev and ops for good DevOps. So we'll have a control plane to manage the whole thing, and Kubernetes container orchestration, container registries. Mike will talk about build service, and it's going to run on data center infrastructure back with vSphere on top of that. So lots of things we need to go up the mountain, Mike.
You're right, Pam, absolutely. But lo and behold, we're already at our first major camp, and we're slowly making our way up the mountain. As we've decided what our route and our plan look like, it's time to start building out the foundation of what the architecture will look like when we get to the summit.
So we know we're going to need a Kubernetes and container platform, and I can certainly build it all myself. There's a lot of open source out there, but that might not be the shortest way and the most efficient way up the mountain. This is the stack that I would have to build. vSphere sitting on the physical infrastructure, I would have to have storage persistence. I will need security and networking integrated. I want to be able to manage the Kubernetes clusters, the platform itself, and there'll be orchestration and service creation via Kubernetes. I'll need a container image registry. And of course, I have to wrap all this with monitoring, logging, and the ability to troubleshoot. And I need to keep in mind that Kubernetes change quite frequently. This sounds like an awful lot for me to manage. Not sure I want to go that route. I've heard about vSphere 7 with Kubernetes, part of the VMware Tanzu portfolio. I'd like to head that way.
Well, it's great to hear that we have a platform selected, Pam. Now we really need to start thinking about what the developer workflow looks like. How is this world of microservices going to change the way in which our developers work? First and foremost, at the forefront of their considerations are going to need to be containers. So what exactly makes a Docker container? How are we going to have our development team, who's been so focused on deploying applications to VMs start to understand what's involved in building a Docker container. Well, a Docker container, as Pam stated, is a collection of layers, a small and efficient footprint in which the application and its corresponding dependencies are able to run in. Now, these Docker containers are essentially made of thin read-write layers, and a combination of those layers ultimately add up to make a container. But this is maybe the first sign of trouble that we see on the mountain itself. We have a bunch of application developers who are very, very familiar with Windows and Windows Server, and now we're going to introduce Linux to the mix. So what makes this so complicated to the introduction of containers to both our developers and to our operators? Again, let's take a look at the flow today. With continuous integration in place, Jenkins is able to take our code from its Git repository and build a collection of .NET WCF assemblies and DLLs. From there, Jenkins will run our corresponding unit tests once the application is built, and finally, assuming all things pass, get deployed out to dev. As we mentioned earlier, it's a manual propagation from dev to staging and subsequently from staging to production. Let's take a look at how the workflow could potentially change as we introduce our container and microservice workflow. You'll see that aside from the C# files that our developers are used to writing, we're going to need to actually add some YAML configurations as well. The deployment artifact for this new branch of code and this new code base will be a Linux container, as you see here. We'll ultimately still run through the same NUnit test process. And then lastly, with Tanzu and vSphere with Kubernetes targeted, we'll have to look at a tool like Harness to figure out what steps we need to take in order for us to deploy this into Tanzu. But just look at all of the new aspects and components of this workflow that are either new to the developer, new to the operator, or both. So looking at that and understanding the new elements that are part of the workflow, how can we also lean on the Tanzu product portfolio? Well, it just so turns out that the Tanzu build service, coupled with the Tanzu application catalog, could make this build process a little bit easier on our developers. It could provide a level of abstraction that simplifies the new introduction to a world of containers and a world of microservices.
Great. Well, let's dive into some of the component parts. We know we're going to have a Kubernetes platform, and we've chosen vSphere 7 with Kubernetes, also called vSphere 7 with Tanzu. It provides a unified platform for running both VMs and containers. This means the platform operator, such as myself, manages and supports the environment using the familiar tools I'm used to, while the developers, like Mike, consume the Kubernetes clusters using the tools they're used to. Let's take a quick look at this overview of the architecture. And remember, we're about to drop into a demo to show you vSphere 7 with Tanzu in just a couple of moments. The hybrid services fabric unites vSphere and Kubernetes. Kubernetes is embedded in the ESXi hypervisor and is managed by the vSphere supervisor cluster. Supervisor clusters are mapped one-to-one to vSphere clusters. Storage services leverage vSphere Cloud Native Storage, or CNS, to provide Kubernetes clusters with stateful application support through persistent volumes backed by vSphere storage. Network services leverage the integrated NSX to provide such things as Tier 1 gateways, load balancers, and multi-tenancy from the network perspective. Tanzu Kubernetes grid services are used to provide the upstream compliant Kubernetes clusters called TKG clusters. TKG clusters are what most developers will prefer to use, and indeed what Mike will use during the rest of this talk. Pod services complement Tanzu Kubernetes grid services by creating Kubernetes clusters that are a native part of the ESXi hypervisor. This provides the same hypervisor level of performance and security isolation to Kubernetes clusters that you're used to with virtual machines. Kubernetes clusters created by the pod services are called pods. While these clusters are not upstream compliant clusters, they are a great complement to the TKG clusters, which are. Finally, namespaces here across the top or how you provide multi-tenancy for applications and developers. Each namespace runs in the supervisor cluster and is backed by a resource pool. That allows you to control resource utilization and permissions for all Kubernetes clusters in the namespace. vSphere 7 with Tanzu provides both developers and platform operators with a really practical platform to realize the benefits of Kubernetes containers alongside with virtual machines. I think we should jump into a demo now and take a look at some of these concepts in person.
Sounds great, Pam.
Now that we've decided to use vSphere 7 with Tanzu, let's learn a little bit more about it. Then we'll create Mike a cluster to use for modernizing his application. We're using the same vCenter user interface that you're used to. Mike's current monolithic application is running in production in a virtual machine we've named VMworld VM. In a bit, Mike will tell you more about the application running there. vSphere 7 with Tanzu, as we saw during the slide presentation, tightly integrates Kubernetes with vSphere. The supervisor cluster is the control plane and management layer. This cluster runs on the ESXi hypervisor directly. It has 3 supervisor control plane VMs and uses these 3 ESXi hosts as its worker nodes. On the right, we see the supervisor cluster is running. We see its version of Kubernetes and its control plane node IP address, 10.50.0.1. This is the IP address we will use in the YAML file when we create Mike's cluster in just a bit. While the supervisor cluster is very powerful and offers the security inherent in vSphere, it is not an upstream compliant Kubernetes distribution. That is where Tanzu Kubernetes clusters come into play. They are upstream Kubernetes compliant and are what most developers will use. We will create a new cluster for Mike in just a moment to show you that process. But first, let's use a cluster that we built previously to show some examples. Namespaces are a very important concept because they provide multi-tenancy and are backed by resource pools to allow you to control resource utilization and permissions for any Kubernetes cluster in the namespace. Let's take a look at the namespace we created earlier for Mike. Mike Dev. You can see it is running, it's active. Mike has permissions to use it. There's storage attached to it. We've set some limits, and there's one Kubernetes cluster running, Mike Dev Cluster. If we expand here, we can see Mike Dev Cluster has a control plane virtual machine and a single worker node. This is a demo, so we're using one node for each. In real life, you would have multiple control planes and multiple worker loads where the containers would be running. Now let's go to NSX Manager to see how tightly NSX is integrated with vSphere 7 with Tanzu. Every time a cluster is created, a Tier 1 gateway is also created. This provides the necessary isolation for the cluster from a network perspective. Let's expand. We have 6. Let's expand and we'll see Mike's Tier 1 gateway for his cluster, Mike Dev Cluster, and the 2 VMs, one the control plane and one the worker node. Similarly, for every time a cluster is created, a load balancer is also created. This load balancer is used to distribute the workloads across the worker nodes. Now that we have reviewed some of the components of vSphere 7 with Tanzu, let's create Mike a cluster so that he can use it to develop his microservices application. The first thing we'll want to do before we create Mike's Kubernetes cluster is to create the namespace in which the cluster will reside. So let's go to vCenter, Workload Management, and we'll pick New Namespace. Namespace is run in the supervisor cluster, so we'll select that and we'll give it a name and a brief description. Namespaces start running fairly quickly. You can see it's active and it's running and it's on our supervisor cluster as expected. We'll now need to give Mike permission. We'll select vSphere.local as the identity source, start typing Mike's name and select it, and then give him edit rights to the namespace. We also need to add storage. Storage profile is a vSphere policy which will automatically create a Kubernetes storage class. Keep this name in mind when we view the YAML file for creating the cluster. We could also set limits. Namespaces are backed by resource pools. So if we wanted to limit the consumption by, say, a group of developers, we could do that here. We'll just leave it alone for this purpose. So the namespace is created, but we don't have any Tanzu Kubernetes clusters running. So let's go create one. The first thing we'll do is we'll take a look at the YAML file, which we'll use to create the cluster. We see we'll create a Tanzu Kubernetes cluster, upstream compliant cluster, named CMike dev cluster. It will have a control plane VM and one worker VM. If it wasn't a demo, we would have multiple control planes and multiple workers. Both of these nodes will use the Kubernetes class best effort small. Each version of Kubernetes may provide slightly different size VMs for these classes, but you can check the VMware documentation for current sizes in terms of CPU, memory, and storage. For example, the best effort small class here creates VMs with 2 virtual CPUs, 4 gigs of memory, and 16 gigs of storage. Now for cluster storage, we'll be using the Kubernetes storage class Tanzu storage profile. This class was automatically created when we selected this Tanzu storage profile in vCenter. And finally, we're using the version 1.17 distribution of Kubernetes. Let's go to the command line to make Mike's cluster. First, we'll log in to the vSphere supervisor cluster. And then we'll switch the context to the namespace that we just created for Mike. This makes sure the cluster is created in his namespace. Now we'll run the command to apply the YAML file and create the cluster. Looks like it worked. Let's get a little more info. And there it is. At least it's starting to be created. You can see in the phase here. The name will be CMike dev cluster, and it'll have the 1 control plane and the 1 worker as we described in the YAML file. We also are using version 1.17 of the distribution, Kubernetes distribution. Let's go back to vCenter, see what's happening there. See the new namespace that we created. It doesn't yet have a Kubernetes cluster. That's most likely because we're still powering things on. We'll give it a moment. We can see that Mike's cluster is fully provisioned and both the control plane and the worker node are spun up. If we go again and look at the namespace that we created this cluster in, we see our regular permissions, storage, but as we scroll down, we can now see there is a Kubernetes cluster running here. Let's take a look at NSX and see what has happened there. If we go to the network topology, we'll expand the number of tier 1 gateways, because if you remember, a tier 1 gateway is created for every cluster. We can see here, tier 1 gateway is created for Mike's cluster. And if we move down and expand the VMs, we'll see the control plane VM and the worker VM that was spun up for Mike's cluster. Similarly, a load balancer was also created to distribute the workloads across the worker nodes if we had more than one. One last thing to show you before I turn it over to Mike is the content library. The content library is a really cool feature. It can be synced with VMware to automatically pull the latest Kubernetes distribution. You can see here we have a couple of version 1.6 and a couple of version 1.7. If you'll remember, we requested in our YAML file version 1.17 of the distribution. The nice thing about the content library is when I request 1.17, the latest version of 1.7 will be chosen. In this case, 1.17.8. And if we go back and check the command line where we gathered information about the cluster we created, we'll see version 1.17.8. This makes it really easy for me to keep the developers up to speed and with the latest Kubernetes distribution. So that's it. We'll turn it over to Mike now to use the cluster we've built to modernize his application.
Thanks so much, Pam. Let's take a look at the existing WCF monolith application first. Here, you will see the legacy WCF monolith. As noted, we will be decomposing this application by first breaking off the Analytics API, while retaining both the News API as well as the Market API. You can see existing endpoints here inside of Visual Studio. As Pam mentioned, our monolithic application is deployed to a VM running under vSphere. When I go to my VMworld VM where the application is installed, I can bring up IIS and I can see the name of my VM here, our VMworld VM. I can see the default website and I can see our monolithic application deployed to the WCF application inside of IIS. Here, I'm going to go and look to see if my service is up and running on the VMworld VM that we just looked at. I'll paste in my service's address and we'll get the familiar WCF service landing page. From here, I'm going to actually open up Postman and I'm going to try to access some of the endpoints. We'll start first with the News API. You'll see that my service address is the same and that we're using the News endpoint. I'll send that request off and confirm that we're getting data back associated with the News API. Let's try to do the same thing for the price targets. Here I have to pass in a stock symbol, so I'll pass in the letter F for Ford. As you can see, the data is coming back here as well. Let's try it with a different stock. Let's try JP Morgan, JPM, and we'll see that that updates appropriately. Finally, let's take a look at our new Analytics Microservices .NET Core application. This application and microservice will be deployed in a Linux container. Here we're looking at the recommendation trends controller and an endpoint that will provide recommendations based off of a given stock symbol. All right, our development teams are off and running. They're currently underway decomposing the existing .NET WCF monolith and converting the Analytics API into its own Microservices .NET Core application. But as we saw, that new workflow is going to require some new tasks for our development teams. The question is, how can we abstract some of those tasks out of their workflow? How can we use the Tanzu build service in order to simplify the deployment process? And because the Tanzu build service leverages build packs and uses build packs to create container images, how exactly do build packs help us here? Well, they help us in a couple of different ways. The first way is in control. The build packs themselves provide a balanced level of control between app devs and operators. Essentially, the builders themselves become the contracts between both app devs and operators. Operators are aware of what the builders provide and what goes into any container image that's built using the build service. The next added benefit is compliance. Any specific application security compliance requirement that's needed for your organization can actually be baked into the builder itself, therefore ensuring, again, any application teams that are leveraging the build service will ultimately have the ability to get their compliance and security layers built for free. Lastly, maintainability, and this is an important one. Not only is the Tanzu build service watching our repositories, it's actually watching the builders themselves. If a CVE is reported and a builder needs to be updated, once that builder is republished, the Tanzu build service will go out to all the configured repos and rebuild those particular images using the updated builder. So this is a way for keeping us, again, in compliance, in control, as well as keeping us secure when CVEs are reported. How would the Tanzu build service fit into this overall flow for our microservices code base? Here you'll see that we have both a collection of C# files and a limited subset of YAML files. The VMware Tanzu build service would essentially be able to build our Linux container with light configuration, a GitHub repository, and subsequently an application code base, in our case, a .NET Web API, .NET Core Web API. From there, the Tanzu build service would be able to create the container and place it into an artifact repository, in our case, Docker Hub. And then subsequently, we would need to start thinking about what type of continuous delivery tool we would want to leverage in order to move the container from the artifact repository into our development environments to be able to land a continuous delivery-like motion.
Now we want to take a look at the Tanzu build service. So the first thing I'm going to do is I'm going to log into my cluster, get access to it, and I'm going to get corresponding namespaces. As you can see, we've got a build service namespace. We've got kpack here, which allow us to use the actual kp commands and look at the available commands associated with it. So what I want to do is I want to look at the corresponding image list here. And you can see our River East Web API container configuration is here. What I want to do now is I want to see the status of the latest build. I just actually made a merge into our source repository, code repository, and I want to see whether or not a build has kicked off. So I'll do kp image status, and then I will provide it with the name of the image configuration, River East Web API. And it looks like the status of it is currently building, which is great. We've got a handful of successful builds and a handful of failed builds based off of configuration changes that we made. We're logged into Docker Hub now, and I can see that my River East Web API repository has a set of corresponding images located within it. These images were pushed automatically when successful image builds were completed by the Tanzu build service. Now the question is, when a corresponding image is uploaded into this repository, how can we continue the movement into a continuous delivery motion to get these images deployed back to our Tanzu vSphere clusters?
All right, we've got our platform selected, we've got our platform deployed, we've got our first iteration of our .NET Core microservice and its corresponding container build being handled by the Tanzu build service. We're now officially at the third campsite, storage, management, and continuous delivery of our application inside of our new platform.
All right, so let's first talk about storage. Now, the current application doesn't require any application state, but your next application, Mike, I believe will. So that means we're going to have persistent storage on the back end to support you. So why do people consider this hard? Well, the first thing is, if you're not using vSphere 7 with Tanzu, you're going to have to make sure that your storage platform supports the container storage interface that matches the version of Kubernetes that you are going to deploy. Second, any feature and functionality is dictated by the storage platform keeping up with the Kubernetes version. And also, you must configure the Kubernetes cluster and all the worker nodes with the CSI. So that means anytime Kubernetes upgrades or there's a CSI upgrade, you have to manage it. It also means you have to continue to manually to test the compatibility of the entire system. Anytime a CSI changes from the storage platform, anytime you want new Kubernetes capabilities. So there's some risk and a lot of misconfigurations, a lot of complexities, and a lot of snowflakes. As we saw in the vSphere 7 with Tanzu demo, vSphere storage policies automatically create Kubernetes storage classes for consumption by the apps running in the Kubernetes clusters. If an app, such as the MySQL example here, needs a persistent volume, vSphere 7 with Tanzu leverages vCloud Native's storage service through the CNS control plane to provide those persistent volumes, which are backed by vSphere. The developer simply uses the appropriate YAML command to request it. Here's an excerpt from a YAML file showing an example. You can see that the kind here in the YAML file requests a persistent volume claim. That will actually show up in the namespace as a persistent volume claim in vSphere. vSAN and any supported vSphere storage provide this capability. vVols are supported along with encryption, snapshots, and volume resizing. Most likely, you and your organization are going to be very successful using Kubernetes and containers to modernize your applications. And you might end up with a variety of clusters in many locations, some VMware Tanzu, some in Amazon or Azure. Tanzu Mission Control allows the platform operator to centrally manage and monitor these disparate clusters.
Well, Pam, we're coming up on the final leg of our journey. How can we institute continuous delivery with our new microservice application on top of the VMware Tanzu portfolio? One of the things that I love about this new Kubernetes ecosystem is all of the specialized tools that have come to prominence over the course of the last couple of years. Harness.io is a continuous delivery specialized platform that really focuses on the last mile of continuous integration, continuous delivery. We're going to use Harness in order to get our artifact that's been built by the VMware Tanzu service actually up and running on Kubernetes on VMware Tanzu.
One of the tools that we like to leverage at Ahead is a tool called Harness, which really simplifies the continuous delivery and continuous deployment motion inside of your delivery pipelines. Here we have a corresponding configuration set up for our River East Web API microservice. Now, in order to set something like this up, we have to provide a bunch of configuration data as it relates to the service, the triggers that we want, as well as the environments. So here, in terms of triggers, what we want to do is looking at the artifact source, which was our Docker Hub repository that we just looked at. Anytime a corresponding source artifact has been updated or added, we want that to trigger the CD process for us here. You can see that we have a pipeline set up. This pipeline is very simple. We deploy the web API container to dev. There's some sort of approval process, and then we deploy it to production. One of the other nice things is that we have the ability to set up workflows as well as environments. So you'll see that in the environments section, we have a non-production, which has my dev cluster, as well as a production, which contains my production cluster. Let's go and look at some of the previous deployments that have happened based off of the images that we saw in the Docker Hub repository. You can see that the last couple of images that have been uploaded have kicked off the CD process, and ultimately the CD process has delivered the web API container and analytic API microservice to both deb, and then once approved out to production. This is just another example how a tool like Harness that focuses in on a specific area of the pipeline process can be used in conjunction with the Tanzu build service, as well as any Kubernetes cluster within Tanzu to be able to deploy an artifact, in this case a container of our choice.
Well, this is the last step of our demo process today. We want to ensure that Harness has actually taken the build image and deployed it to the Tanzu cluster that Pam set up for me earlier. I'm just going to come in and set my context appropriately. Then I'm going to come in and I'm going to look at the namespaces in my cluster. And you'll see I've got River East Dev and River East Prod, just as we saw it in Harness. And I'm going to get services. Associated with my dev namespace. And we can see that the service is up and running, and I'll have an external IP to be able to connect to in order to hit my API.
Right, I was able to bring up my deployment, and I was able to hit the endpoint here at the external IP that was provided along with the corresponding port. I'm going to do the same thing. I've already run it for JP Morgan. I'm going to do the same thing for Ford. That looks great. Similarly, I can try out the recommendations API endpoint inside of my analytics microservice as well. Here I'll look at the corresponding recommendation trends for Citibank. You can see that that comes with data back. So now at this point we have our monolith running in our Windows VM. We've taken the analytics API controller out and put it into its own microservice. We now have that running up and accessible on Kubernetes.
Well, Pam, we made it. We've reached the summit. Our microservice application and corresponding containers are in production, and they're running on top of vSphere 7 with Kubernetes. Our journey is now complete. To wrap up today's conversation and to highlight where both operators and developers can go from here, let's take a step back.
Yes, it's been a great journey with you, Mike. I think for everybody out there in the audience that wants to get started on a similar journey, there are the hands-on labs from VMware. They're both listed there. There is the starting introduction for vSphere administrators to Kubernetes 101, and continue to check out the community mindshare from ahead dedicated to Tanzu. You'll see demos, white papers, and other information that you can use there.
Thanks, Pam. I too have enjoyed today's journey. For all of us looking to make our next journey are those organizations who've yet to start out. A couple of handy resources, a head state of the modern apps ebook, as well as a head scaled DevOps report can be useful resources to see the routes that other organizations have traveled up the mountain. And then lastly, to understand and learn more about cloud native build packs, you can check out either the Tanzu build service or the CNCF cloud native build packs website. Well, Pam, we've done it. We've made it all the way up to Mount Kilimanjaro summit, and we've accomplished so many great things along the way. Today, we were able to showcase a hybrid ops model for both virtual machines and containers using vSphere 7 with Kubernetes. We moved from a .NET monolith to a hybrid app architecture hosted across both Windows VMs and Linux containers using vSphere with Kubernetes. We displayed how to use the Tanzu build service and how it could offload developer concerns around building lean and secure Linux containers. We also instituted continuous delivery on vSphere 7 with Kubernetes using harness.io. Today's been a great day.
Well, thanks everybody for joining us on our climb today, and good luck with whatever mountain you decide to climb.
Thank you.